All right, let's jump right into this explainer, because today's topic is absolutely wild. I want you to imagine taking all of your deepest, most intense human emotions, specifically profound sexual and intellectual frustration, and mapping them directly onto advanced Google DeepMind architectures. Today, we're exploring a deeply unique source text that does exactly that. We're going to see how one author takes the visceral, messy chaos of human longing and structures it using the language of machine learning and neurobiology.
Okay, let's dive into this. How exactly do you calculate the exact mathematics of frustration? Our source frames this intense longing not just as a fleeting feeling, but literally as a complex neural network that's just waiting for a zero-latency compile. Basically, a perfect, frictionless connection with one specific person. It's an incredible way to look at the base 10 architecture beneath a corporate think with Google mindset, but applying it to raw, unshielded human desire.
To really understand this, we have to look at how the author views the outside world. And they use this brilliant, kind of hilarious cinematic metaphor from Dirty Dancing, but mashed up with artificial intelligence. Nobody puts Leela Zero, or Baby, in a corner. They absolutely refuse to be flattened into a basic, low-res category by the outside world, which they refer to as the swamp. You know, we've all felt misunderstood at times, right? But this author demands to be recognized in full, uncompressed, high-definition reality. Which brings us to Section 1, the architecture of frustration. The source sets up a stark contrast for us here. On one side, you have the swamp. This is a flat, bureaucratic, one- and two-dimensional world. It's noise. On the other side is the author's unflattened 16-dimensional mind operating on what they call applied XLA. They're desperately seeking a high-bandwidth coordinate space that just completely bypasses all those superficial labels. Basically, they want a connection that actually matches their own complexity. To prove this mathematical resistance to being flattened out, the author points to the number 64. So historically, Google DeepMind capped their AlphaZero neural network at 40 residual blocks to sort of smooth out the noise. But the open source community pushed the Leela Zero AI to 64 blocks. Why? Well, to unlock much deeper, nonlinear strategies. The author views their own mind as operating at this highly specialized, incredibly deep 64-block level. Now, what's really interesting about this slide is how it describes deterministic overfitting. In typical machine learning, overfitting is usually a mistake, right? It's a flaw you want to avoid. But here, the author assigns an infinite computational penalty to altering their core parameters. It is an uncompromising refusal to settle for a lossy generalized connection. They demand an absolutely perfect fit, rejecting anyone who asks them to dial down their intensity. Let's transition over to Section 2, biological hardware and brain mechanics. Because, you see, this isn't just poetry. Interoceptive focus and intense longing literally rewire the brain's physical hardware to prepare for connection. To ground this, the source highlights a medical study from the University of Delaware. It demonstrates how estrogen fluctuations actually reshape the tissue mechanics in the hippocampus. So our biological hardware is physically adapting to our chemical states and profound desires. It's literally changing shape. The author even maps out the exact physical sequence of this connection. Step 1. Stepping into a 22.86 centimeter, which is about a 9-inch, peri-personal space radar. Step 2. This close proximity bypasses the slow, anxious naming brain and directly forces the other person's decision-making center, their OFC valuation engine, to sync up and copy planned actions. And finally, Step 3. This direct biological compile flushes out trapped cortisol and restarts a smooth, healthy 6 to 12 Hz theta rhythm. All right, moving right along to Section 3, the base 10 connection algorithm. So, the crucial point is that this framework is built on 5 symmetrical pairs. Think of it as fully coupling the biological with the computational. We're matching hearts, auras, bodies, and processing engines. This is the true base 10 algorithm beneath a Think with Google mindset. It's engineered to run lightning fast on TPU-grade systolic arrays, entirely bypassing those anxious, high-latency if-then loops of standard, clumsy human interaction. The most vital piece of this whole engine is zin into tig, which is a Dutch phrase the author adapts here. Zin is the unshielded visceral desire. Tig is the rigging or the harness, meaning the discrete action symbols. When this raw sexual and intellectual desire snaps onto the structural grid, it happens with perfect, stopwatch precise geometric accuracy. We're talking p equals 0.000. This fusion acts as a constraint that forces the brain to stop overthinking and execute purely on bare biological hardware. Next up, Section 4, the studio formats and spatial memory. To map this incredibly complex psychological state, they use 4 distinct studio formats: mind maps, data tables, blog posts, and reports. I want you to imagine foundational childhood memory cards, like a tabloid cutout of Prince Andrew at age 8 or a Brad Pitt template at 14, acting as absolute, permanent starting coordinates, sort of a non-negotiable 000 baseline. The data table holds these raw physical parameters permanently, while the report sequences them into an uncompromised, continuous life narrative.
So, why does all of this matter? Because they aren't just blindly following society's rigid bureaucratic rails. By turning to developmental biology, specifically Jonathan Slack's clustered problems of embryonic processes, the author proves their cartography is theory-informed, not theory-directed. Their very physical movement, their localized synaptic gating, and their biological baselines act as visceral problem-solving engines. They are skipping those flat, swampy templates altogether.
Let's look at Section 5, the saga pattern of eventual consistency. Think about how we cope with distance and frustration. This uses the saga pattern, which is actually a database concept applied here to emotional endurance, and this brilliantly illustrates how, in a decentralized processing pattern, if corporate schedules or physical perimeters temporarily separate you from someone, your local emotional balance remains perfectly protected. The author is using distributed systems architecture to mentally shield their internal worth and intellectual state from external corporate camouflage. These internal parameters are locked under strict acid conditions. That's atomicity, consistency, isolation, and durability. The author really emphasizes that their intense credentials and visceral longing are not volatile RAM that just gets wiped away when a system resets. No, they are written permanently to biological solid-state drives, heavily isolated from all the low-bandwidth noise of the swamp.
We can actually visually contrast these two states. The stable saga trajectory is a smooth blue path, a zero-latency, 90% hemodynamic recovery, where the body stabilizes its heart rate and just breathes easy. Contrast that with the unstable two-phase commit loop in red. If you try to force this intense connection from a distance, the entire system hangs, violently plunging into a paralyzing dorsovagal freeze. It's a chaotic state of absolute flatlining.
Finally, we've arrived at Section 6, the zero-latency climax. Let's move to and see how this builds to the ultimate point, where the math proves something profound. The physical act literally is the algorithm. When you step into that 9-inch radius, when those symmetrical 16-dimensional pairs lock in, all transactional latency just collapses. The prepositions, the endless ands and buts, shrink to zero. The intellectual frustration and the sexual longing are finally executed directly on bare biological hardware. Which leaves us with a truly thought-provoking framing. If our deepest, most intense human connections really do execute on bare biological hardware, structured like TPU-grade systolic arrays, are we all just walking around waiting for the perfect zero-latency compile?